Hello everyone, welcome to my channel. Today we're going to discuss about spanning tree protocol. In these sections, we're going to see how spanning protocol functions, how to configure root bridge, and how to configure designated port, root port, and block port. Overall, how spanning tree protocol functions, we're going to have a look in these sections. So let's have a look in details.
In this topology, we have switch 1, switch 2, and switch 3. So switch main job is it's forward the frame, right? Switch main job is it can forward the frame. Now, if we send something from this PC, let's put the name at first. This is, we put from here, PC1, this is PC2, and PC3. So if PC3 want to send something to PC1, then it can use two links. It can send this way, and also it can send via switch 2. So if switch 3 want to send traffic, it has two links. So switch main characteristic is it can always send traffic. So the problem is if this both links are open, then frame will go this way and frame will also go that way. So that means both way frame will go. And sometimes if this destination's address is down, then this frame will continuously loop around that network because switch can only forward the frame. So this switch forward the frame there, this switch sent the frame over there, then this switch again forward the frame to this one. So this kind of things happen in the network because switch main job is forward frame. Now, if these two links are open, then if switch 3 sends some frame, so this link will send the frame, also this link will send the frame. So switch 1 will receive multiple copies of frame. And if these things continuously happen in the network, this switch 1 will receive many frames. Unnecessarily, it will receive many frames. To avoid these things, we have spanning tree protocol, which is STP. STP main job is loop prevention. This is its main job. So STP by default will be enabled inside our network, but we can configure which switch will be the main switch, which other switch will be secondary switch, and how STP will functions. We can configure those things inside our switch. Now, every switch by default, we have two things. One is priority, which is 32,768. That's kind of like a default priority. And also switch will have base MAC address that is kind of like that. That's the switch MAC address. By default, every switch, they will have a default priority and they will have MAC address. Same thing with switch 2, it will have a default priority and MAC address. And switch 3 will have a default priority and also MAC address. Now, when switch, they are connected in this way, like this one with switch 1, this switch 2 also with switch 1, and they have all the connectivity from all directions. In this scenario, STP actually do one of the election process inside this network and make one switch as a root switch or root bridge. The switch who has a lower priority, that switch will be the root bridge. So in this case, if we see switch 1 priority, switch 2 priority, switch 3 priority, they're all same, right? But Condition is if switch has a lower priority, that switch will be the root bridge. But if priority they are same, then switch who has a lower MAC address, that switch will be the root bridge. So in this case, all the priorities they are same. So this switch has a lower MAC address because it starts with 1, this is start with 2, this one start with 3. So this one has lower MAC address. So this switch will be the root bridge. Root bridge means this switch will be kind of core switch, main switch. And other switch, for example, switch 2, it will be non-root bridge. Then same this one, it will be non-root bridge. Because this switch has a lower MAC address, that's why this is the root bridge. Root bridge means that switch is the main switch, and all other switch, they will find the best path to go to root bridge, and all other switch, they will forward the frame towards root bridge. But this is, we are looking at default scenarios. Let's say priority they are same, all the switch they are connected with each other, and one of the switch who has lower MAC address, that switch win and becoming root bridge. So if this is root bridge, all the port will be DP, designated port, DP. DP. What is designated port? Designated port means forwarding port. DP means forwarding. Forwarding port, or we call it active. It can send and receive frame. That means it's active port. Okay. And STP, we have the 3 different kind of port. Another port we have root port. Root port is, this is RP. Root port, forward frame 2 towards DP. And another one we have BP, blocking port. That's kind of block port. So designated port, root port, and block port. This kind of port we have in spanning tree protocol. Now, DP means they are active port, they're able to send and receive. That's one conditions. After that, let's move to this switch 3. Now switch 3, it has 2 links to reach to the root bridge. So which way it will go? It will then check the cost. Let's say this, this link, this is 100 Mbps speed, so cost is 19. We have STP cost. STP cost means if it is a 100 MB link, cost equal to 19. If it is 1000 MB link, cost equal to 4. That's the default STP cost value we have. It's based on the link. Let's say we have 100 meg link, cost is 19. This is another 100 meg link, cost will be 19. This is another link, cost will be 19. So 19, 19, 19. Now switch 3 point of view, switch 3 can send traffic this way, cost is 19. But if sends via this way, cost will be 38. So this path is expensive. And this path is shortest path or better path. So this link will be open and this port will be RP. So in this way, this port will be root port. Every non-root bridge switch will have root port. After that, this link is expensive for this switch 3 link. So something has to block. So this port will be blocked or this port will be blocked. It depends on the MAC address. higher the MAC address, that port will be blocked. So this port will be BP. BP means block port. And every link you must have to have a one DP. This one will be DP. Because every link you must have to have one DP. So this port will be DP. After that, this switch 2 point of view, it need to send traffic to switch 1. So this one will be RP. Because RP forward the frame towards DP. And every non-root bridge, this is a non-root bridge. Every non-root bridge, they have at least one port need to be RP. So they have one port RP. So in this way, switch 3 will be able to send traffic via this link, and switch 2 will be sent traffic via this link. And in this way, there will be no loop in the network. Let's say this PC want to send traffic, it will go just this way direct in here and there. After that, this switch 2 want to send something to this PC1, it will go this way. And also if switch 2 or this PC2 want to send something to switch 3, it will actually go via the root bridge, then it will go there. It will not use this link because this is a block port. All the switch has to follow root bridge. So it will go this way. But main aim is loop preventions. In this way, there will be no loop in the network because all the switch, they have only one link open, so they can send the traffic via that link. So these things automatically happen inside the network. If we do not do any configurations, then these pictures is actually happening in the backend. By default, Cisco device STP is enabled, so there will be no loop in the network. But in the backend, that's how these things functions. But in our context, let's say this is the default features. Now let's say when you do hierarchical network design, then we have the structure like that. And you got like, a couple of PC in here. So this is the structures we have. Now this one, let's say this is our core switch. Core switch means this is our main switch. And then they are like a distribution layer switch. This is a DS switch as well. And this is access layer switch. This is according to our network design. That's how we should be placing our switch. So in this scenario, we'd like to have, core switch. So if you connect all the switch together, after that, redundancy purposes, we have multiple link as well. We have multiple link. All the link, they're connected in this way. Now these scenarios, we have many different link, many different way we can reach to core switch. So this scenario, STP is very important. By default, if you connect all the device, they will do the election process automatically and create one of the switch as like a root switch or root bridge. But for example, if this device becoming root bridge, if like this access, if this is a root bridge, then what will happen? All the traffic flow will go that way, and then it will go to other place. So we do not want this one to be root bridge. We want maybe our core switch to the root bridge. In this way, all the communications will happen via the core switch. All the switch, they will find the best way to reach the core switch. And after that, core switch will be connected with routers. This is the routers. So that's how when you design the network, that time you specify which particular device you want to make a root bridge. So this is a STP concept.
I hope this information was useful for you and thank you for watching.